Hey everyone, welcome back to our statistics class notes. We're here at the bottom of page 122 and moving on to page 123 here in section 8.2. We're in the middle of doing a hypothesis test for a population proportion. Remember, we hypothesized that P was 0.68, which is hypothesizing the proportion of all Americans who support stricter gun control laws is 68% based on an October 2017 data. And then we did a sample in February of 2018 where we got about 75% in our sample. Got 754 people out of 1,005. So we want to know if that 75% sample is enough indication statistically to say we can reject the null, which means we don't believe the support of Americans is at 68%. We believe it's more around, it's something greater, right, from our sample, something greater than 68%, because the alternative is that P is greater than 0.68. Okay, so I was going to show you now how to do it with StatCrunch. So here's the directions. Go to Stat, Proportion Stats, one sample, just like you do for confidence intervals. With summary again, because we don't have the data here. We just have a summary. We got 754 out of 1,005. We don't have all the yeses, nos. Okay, the number of successes is your 754. That's n times p hat if it wasn't explicitly given to you as 754. The observations is sample size. Otherwise, it's the same for doing it for confidence intervals. Just we have to now choose hypothesis test and enter the correct null and alternate hypothesis. So let's do that. So I'm going to go to Stat, Proportion Stats, one sample with summary. Number of successes we had were 754. Observations we had were 1,005. And now we got hypothesis test. We got to put in the correct null and alternative hypothesis. So remember, we have the population proportion that we expect from the past is 68%, so P equals 0.68. And we want an alternate that is strictly greater than. We want a one-sided right test that it's greater than that 0.68. That's all you need. Okay, so we'll go ahead and hit compute. And then here is your results, right? So 754 out of 1,005 is our sample proportion of a 0.7502 like I did by hand. Standard error of 0.0147 like we did by hand. And the z-score of 4.7, your test statistic of 4.77. Certainly that's going to be a really small p-value, less than 0.0001. Okay, so now we'll go back to our notes. And this is the table that we want to go ahead and fill in, which I just read off, okay, which is the results from the hypothesis test. And we can see that assuming that the population is really 0.68 in the middle, our test statistic out here at 4.77, the p-value is the area from there out in the tail. Of course, you can't even see it. I kind of drew a line to say, hey, there is something there, but it's really small, less than 0.0001. So what does that p-value mean? It means that if 68% was still the correct true population percentage, the p-value is a probability of getting that test statistic or one more extreme, the area in the tail beyond it. So is that strong evidence to reject a null? Very strong. P hat is 4.77 standard errors above P naught, which we assumed was the middle. Not likely to get a sample out there if that's correct. So really we have enough information to reject that this is correct and that it's something bigger than that, which is supporting our alternative. So we reject this. The p-value is certainly much less than alpha. So since the p-value is less than alpha, which was 0.05, we reject the null, H naught, and conclude there is sufficient statistical evidence to support the alternative, HA, that is, that national support of stricter gun control laws has increased.